So when we talk about AI assisted coding, I think there's kind of two types, right? So there's basically, as the developer is writing, there's kind of like an autocomplete. And then the other end of the spectrum is where you're providing a prompt and it's basically just auto-completing essentially large code bases and making changes to large code bases. So you're kind of working more on the latter side, I understand. Is that right?
That's correct. I think I started off with the autocomplete stuff, and that was good. You just write the function definition, and it would try to complete the function. It would get good at that, and then it got good at completing out small subunits, and now I think it's building out full apps. So I started from that end of the spectrum where I was just using it as a glorified autocomplete to now it's running a lot of the show in my company for sure.
So let's start kind of broad picture and talk about the workflow, right? So in a traditional software development process, you have the kind of requirements gathering done by the product manager. Then you develop some screens in a lo-fi, hi-fi. Then you basically, maybe you build a prototype, but then you go into development and then you do testing, release it to users, user acceptance. And then, but in this sort of kind of based coding, it almost seems to be the case that you write out your prompt or your requirements, and it just builds the whole thing, and then you kind of are then trying to almost like chisel away at it to kind of make it what you want. So it seems like you start with the end, right? Whereas normally you're kind of building bottom up. Like, it's almost like you're building a house and you're starting with the blueprint and everything, and you're sort of building. It's almost like, it feels like, my understanding is, it feels like you start with the end and then you're trying to like debug it. Is that how you're finding it, or how is it working for you?
Top down or bottom up build.
So for the long living code base situation, and how are you breaking it down into modules or the different pieces as you described it?
Yeah.
And like, how do you draw the line of what a piece is? And then for that piece, is that kind of this kind of sculpting approach, or is that kind of a auto completion approach, or is it a mix, or how does that work?
Right. A couple of things really help me here. The first is that it's a lot of extensive architecture planning. It's a lot of planning of what I want the full house to look like. Like a lot of time spent on the blueprint of the house, if we're continuing the house analogy, right? I'm going down and I'm like, okay, like before you lay on the actual bricks, I want to know the dimensions of every room. I want to know exactly where the bed would be, right? I want to know where the doorway is and what does it lead to if it just talk. I'm just extending this analogy further. But that's the idea, right? I'm spending a lot of time and I'm doing this in collaboration with AI. So I tell them that, hey, I start with a very vague requirement. I ask it to spit out a really large requirement document, and that's all in English, right? Just telling me that these are the endpoints that I want to be building. These are the tests that I want you to write, right? These are the edge cases I wanted to handle. Once I'm done with this large requirement, then I ask AI itself to break it up. I'm like, okay, now if you had like 3 or 4 engineers, how would you break this piece up, and start building it out piece by piece? The one additional thing that has really helped me in doing this is that when you're stuck in some problem, and you will get stuck at some point when you're trying to, and the AI will make a change that goes past you, or you won't notice, or you won't test for. It really helps to give the entire code base to a large language model and help it just like diagnose like one line that's off or missing or wrong or not working correctly. So it's really good at that. And for you to be able to do that, you want the code base to be somewhere in the line range, like less than a 20,000 line range. So when I'm making these rooms of these pieces, I try to modularize it at that level. So I'm like, okay, you're just doing this 20,000 line piece. You don't try to like overextend, and let's try to cut it down to a smaller unit if it goes beyond that. So that's one constraint I put, as opposed to cutting it up as a back end or a front end or a functional thing. I try to break it down into simple enough blocks where I can have it in a to 30,000 line code base that fits very easily in a AI context window, and I can just reason with it if something goes wrong. I try to keep the interfaces very clean. So this block of house just can talk to everything else. So this particular code base needs to talk to the entire system in these APIs or these simple ways. Basically, loosely coupled, highly cohesive systems. The same thing that we talk about in engineering, basically.
Yeah. So it sounds like maybe then you're sort of maybe you're using something like Claude to first put together the requirements document, and then you basically have it, separate it, have the AI tell you how to break it up into modules that have kind of good interfaces. And then basically, then for one particular module, sort of you're defining, I guess, at an architectural level, the interfaces, I suppose. So you, say you give this module to a developer. What happens next? What are they doing?
What is the like? How am I going about the coding bit of it?
Yeah,
Yeah.
of that room or that piece or that module. How are they going about sort of kind of building that code?
So if I trust the design completely, so like let's say I've iterated enough on the design, I'm like, yeah, this design makes sense. This is how I want the building to look like, or this is what the room to look like. I first give it, because it's so cheap in terms of time to try it. I first give the entire requirements without even thinking to this thing, to a cloud code or to a cursor, saying you figure out the steps, you start writing it out, and 7 out of 10 times, maybe 6 out of 10 times, more than half basically, it nails it. Like it gets the piece mostly ready. And so so one path is, it gets it mostly ready, you ask it to write tests, you see what is passing, what is failing, and if it is failing, you try to like either correct the design if it's a design level flaw, or you try to like say that, hey, you messed up something here, this is an exact fix, try and fix it here. Or if it's like a small fix and I know exactly what's going wrong, or if it's misunderstanding some business context, I just try to add context to it. I'm like, hey, you missed this wrong, and try to make this piece perfect. This is if the changes are somewhat in line. If the changes are not in line, let's say if the output is completely wrong, mostly it's my design fault. It's because I've not given it like a really nice clean spec. So I have to like go back a step and be like, okay, really misunderstood what I wanted to build here. Let's see how I want to do this, and that's a learning loop for me as well, because I would have to go through the same loop even if I was coding it myself. Because I start building out something, then I look at the actual data, I'm like, oh no, this doesn't make sense, I need to go back and like fix some of this. The other thing that I do essentially is that I if it's if it's a really obscure language, or if it's a really obscure piece that I'm trying to build and there's like no context for it, then I essentially build it layer by layer, where I'd ask it to, again, like I would break down the functions, and I would ask, then I'd go more towards the autocomplete spectrum, where I know exactly what this file needs to do. So I'd start by saying that, hey, just give me this file, and I'll test each file by file, or each endpoint by endpoint, right? Or even go down to function level for the more trickier bits. But to be honest, that's happening less and less. Like with every passing day, me having to actually go and see what's in a file just keeps happening less, because these models are getting better so quickly.
Right. So basically, if I understand you correctly, so you're looking to put together 20,000 line modules of code. So you're giving it you're saying because it's so quick and cheap, you can basically give it the instructions for building that sort of 20,000 line code, and have it create the test cases and see how it's working. And then you can iterate on the prompts to essentially build that 20,000 line of code and see if it gets there. And you're finding that it's basically working more than half the time to do that. And essentially, when it's not, you're basically starting to give it more instructions, like I need these specific functions, or I need these specific endpoints. And so you're still largely still working on the prompting side rather than kind of writing code by hand-ish
Yeah.
side, it sounds like.
Yeah, the code writing only happens in the events where I'm like, this is too, like, I either it's an understanding gap. I'm not being able to like translate to the AI in English what I exactly want, but I somewhat know what I want to build, and I also want to learn about what I want to build as I'm building it. In the sense that I know how this piece should work, but while I'm building it, I'll think over the architecture details line by line. Old school coding basically. You have like a vague idea and you want to like crystallize it when you're typing the code, but that happens only in like very specific circumstances. By and large, it's still prompting in English, and that gets me most of the crud apps basically get out of the way.
And then, how are you finding the style of code that it creates? Different developers have different preferences for how things are written. Do you kind of have to sort of let go of some of those preferences maybe, or do you have a sense of like that?
When you say preferences, can you give me a little bit of an example? Are you talking about like stuff like linting or like code styling or more high level preferences? Like what's on your mind?
Yeah, I mean, it could be even like the algorithm
Hmm.
used to sort a list, or like, oh, it did it a different way to how I would have done it,
Yeah,
that kind of thing.
yeah.
To what extent do you think that's important, and to what extent is it doing it in a better way, or not understanding what you want? How's that working?
I think it's again like it's so for things like style guides and let's say linting and like this is how my organization writes codes. It's kind of easy to like you have to build up some MCP tools. If you can give it the style guide, or you can say that hey, follow this very standard thing, and you want to essentially defer to the most common standard thing. You don't want to deviate too much from it because the AI will mess up less if you try to stick it to some very well-known standard. Let's say you want to keep it to ESLint or PEP8 for Python or something like that. So it tries to stick to those styling guides. But when it comes to like actual architecture details or like actual implementation details, unless there's a big performance penalty of using like the wrong algorithm or doing stuff in a way that essentially is like making my function really slow or something, I try to like give it control and be like, hey, as long as the interfaces are working correctly, I'm okay. I don't try to like micromanage the code, mostly because I expect in the future it's AI who has to deal with the tech debt as well. It's not going to be
Right.
me. So it's better if the AI writes the code as is, and if it doesn't work, I'll just make AI rewrite it. So
Right. And then when you're thinking about like architecting this, typically in some ways people think about it as like front end and back end, and then maybe breaking it up into different microservices, or are you kind of, because of this kind of 20,000 line kind of
limit.
limit you're working with, are you kind of dividing it up differently or thinking about it differently, or how does that work?
I try to put the 20,000 limit at the end, towards the end. I try to basically do a honest to goodness architecture how I would have anyway. So I want to not over engineer things till I need scale, or till I essentially need to make it complicated. So I try to use my taste, so to speak, in making the best system architecture possible. And once it's done, once it's there, then I try to apply the 20,000 limit, saying that okay, now if I have to break it up, so the 20,000 line limit is not a hard limit per se. It's mostly a softish limit of having enough tokens there. So even if they live in the same repository, or in the same folder, or the quote unquote same code base, that's fine. So that so long as they're functionally separate. So I try to like basically break down the tasks, so to speak, or like modules, so to speak, in 20,000 limits, as opposed to having like entire repositories or entire code bases in 20,000 limits, if that makes sense.
Right, 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 right. So, and then are you doing anything on are you having the AI generate the UX, or user interface code as well, or how does that work?
That's an interesting one. So for my company, essentially for most of the code that I had 9 to 5, it's mostly a B2B startup. So it's not, I don't have very strenuous design requirements. I try to use like a standard component library, so that things don't look horrible and things look mostly okay. And I try to like mostly generate UIs, but I care about design also. So for a lot of my side projects, and I think like if you're like trying to make a B2C product, and design is really important, what's really worked is that you get on Figma, you try to do the design as best as possible, which has to be a step above the AI led design, right? Like you basically want things to be a certain way. Now there are basically these tools that can essentially pull and match the Figma MCP. So this MCPs has been a game changer, so to speak, for front end coding specifically. Two MCPs in specific. One is Figma, which is essentially you can have Figma, have your design there, and the AI will try and pull and try to clone the design as close as possible possible it can, and you give it a browser MCP as well. So once it's done cloning, it will try to whip up, it'll try to like look at the final UI on the browser visually, take a screenshot, and then try to compare, saying that hey, does this match, or are things aligning or not, and try to fix it by itself. So having these two tools gives it like eyes, to so to speak, and that really accelerates the front end development. Having said that, I've not really found a very good AI to design tool yet. They mostly generate okay UIs. I wouldn't call them bad by any stretch of the imagination, but they're not what you'd call a really a good looking app, I would say. They're mostly like vanilla, just okay apps. That's
Yeah.
one thing I'm still waiting for it, like AIs to get really good at.
And then, so using these MCPs for the Figma and the browser, how successful are you finding that in actually creating the code?
It's pretty good in the sense that as long as this is again like how well have you done your requirement specification. If you mostly, so I go on to the level of defining screens, buttons, placements, exactly the charts and graphs that I want, exactly like what drop down should lead to what. And once I've given it that level of detail and I've given it a standard component library, I'm not asking it to like come up with its own components, it mostly does an okay job. So it creates this dashboard, but the doc that I give it is like a huge doc with like everything about it is defined basically.
So, and that's so you're using Claude 4 or something to, is that right?
For the MCP bits, yeah. For coding, I'm either using Gemini 2.5 Pro or Cloud 4. These are the two that I use mostly for coding. I have not had great success with the OpenAI models. I've not tried DeepSeek or one of those open models because yeah, I just pay the most I can for these models and get most of my work from them.
Right. And and then how bug free is the code that is being created?
Yeah, it's not. I think it's not bug free for sure. I think compared to a human, I think it's slightly worse even. Like, if I give it to like a developer to write from scratch, I'd expect lesser bugs from it. There are two things that change the calculus for me. Is the bug spotting good enough? So yes, the code will be buggy, but do you have enough scaffolding to spot those bugs? And because bug spotting, if you can spot those bugs easily, bug fixing is very cheap. So once you point out what the bug is and you can like define what the bug is, generally it does a good job and keeps trying till it solves the bug. So the let's say the cost or the penalty of a bug reduces significantly. Whereas if I give a human a bug, they'd have to load it in their context, they'd have to like traverse the entire code base, understand the offending line, and then figure it out, and then they'd want then get it right immediately. As opposed to an AI does that bit much faster. So it does the bug identification and the offending line bit fast, like the finding much faster. So I let it have a run at the bugs it makes. I just set up a lot of scaffolding around it in terms of testing and like having extensive tests written for everything to catch those bugs. The other underrated thing that I found, let AI do one round of code review before you see the code, because there's just cheap infinite like labor. Just be like, hey, you're an expert code reviewer, look at it and find the bugs. And it sometimes just finds great bugs. Like you're like, hey, I might have missed it if I did the code review, so it's great you did it, and go fix it and come back to me. So that helps. That
So okay. So basically, so when you talk about scaffolding, is that mostly have the test cases that it's also generated, or are there other types of scaffolding that you're using for this kind of bug spotting?
So there are a couple. So one is that I try to preempt the tests as much as possible beforehand in my requirements document. So I tell them that hey, these are the kind of tests that I'm looking for. When essentially before they start even writing the code, they know that these are the tests that they would have to write for or solve for. So that really helps them in writing the actual code. The second kind of the other two aids that I give it for bug fixing is I give it that visual browser thing that I spoke about. So this is really useful for visual bugs where you have like misalignments and like small things that can like they're not like code bugs, but you need to see it to feel it, basically that kind of thing. And it also has the access to browser console. So it has access to any bug that's not coming on your backend but coming on the client's front end. So you get to see a lot of that. The third thing that I give, and this is mostly for backend stuff, is I give it read access to my database, which is essentially, let's say, like today I was writing an ETL pipeline where it was taking like a bunch of data and was transforming it and like putting it into another database, another table basically. And the only thing was the places where it was taking data from was extremely messy. So all these other tables that I have no control over had data in like different places. And as a human, I would have to go read what's in the column names, like actually go read the data to understand, okay, in this situation, this column I have to pick up this column name, but in that situation I have to pick up that column name. And that's how I want to make my ETL pipeline. And instead of me doing that, I basically gave Postgres read access to Claude basically, and was like, hey, each time you build a extraction module, run it and see if the data that you're getting versus the data that the source data are matching. Basically, again, it did like a couple of iterations to like figure it out, but that worked really well, right? So you try to give it enough access to the final data set as well, in which case it can go and build this out.
So basically you're setting it up with you're setting it up with these tools so it runs the code, it can use a browser to look at the application, you can give it basically the bug report and access to the database, and essentially, so this is like within Cursor or something, right? I
No,
assume.
this is literally on Cloud Code. So this I've
Cloud
used.
Code.
Yeah, Cloud Code has MCP access. Of course, also has MCP access. So you could use either, but I mostly use Cloud Code for stuff like this now.
Right. And so, interesting. So basically, it's actually acting like a developer, right? It's basically you give it the information and it goes into your database and goes into, like, it does all of the investigation then, like that you'd normally expect a developer to do to figure out what's wrong with this.
Right. The one thing that I've not tried yet that I would want to try is I have basically, if you're using Sentry or Datadog or any kind of these logging system, is to let loose your AI onto your logging system and let it parse logs, let it look for inefficiencies, let it look for bugs. Because sometimes when you're learning a really large system, you might have like a really corner case bug that comes up once or twice, like it pops up for one user at one point in a specific code path, in which case it'll show up in the bugs, but you'll never actually see it in your tests or production, etc. So I've recently got Sentry up on all my systems, and I'm like monitoring for error events and trying to let Claude look at it and be like, hey, this error shouldn't have come. Why has it come? And try to fix it. But trying to close that loop as well.
Right. Like when you look at your kind of work day or your sort of work week, what proportion of that is kind of the different types of activities? Yeah, how would you bucket that, would you say?
So I'm a solo founder, so I have to do a lot of tech work as well as business work. It's really hard for me to paint a typical week for you. So I have these bursts of like doing a lot of business development work,
Yeah.
followed by I overcommit to my clients about what I'll deliver, and I have to go back and then build a lot of the tech stuff. Then I see my business thing lacking. So it's constantly like trying to pull both sides up. Having said that, every day has a bit of everything for sure. Like some part of my day is definitely like maintenance or like coding for sure, or like working with my engineers to ensure that this is happening. And some part of my day is also talking to clients and understanding their requirements, where again AI has been like super helpful, both in terms of like building out like proposals or building out small decks for them essentially. So it's supercharged that bit as well for me.
So, okay, let's maybe talk about this differently. So, for one of your engineers, then who are building one of these modules or pieces, what if you were looking at it with their day, what proportion of it do you think they are kind of sort of you know working, prompting, and basically sort of building versus maybe debugging? And then I suppose there's also the bug fixing using sort of this agentic approach of giving it access to everything. So How what would be your expectation for your
Sorry.
developers?
See what you meant by the question earlier. But essentially, a lot of it is actually planning for the AI to write new stuff. This is also given the fact that we are a startup and we are just creating our products now. So a lot of it is creation as opposed to maintenance and like bug fixing and like servicing. So basically, we have engineers do two things primarily. One is when they have to create new features, etc., which is the workflow I spoke about, which is a lot of it is actually goes into planning and system architecture. And then essentially executing is has now shrunk. So most of their work is actually figuring out what needs to be built as opposed to how to build it, because that's happening with AI. When it comes to bug fixes and customer service, we essentially have like a we have a separate engineer for that whose whole job is to look at like to get tickets and essentially resolve them using AI again or not using AI. So this person slightly senior can essentially go look at a code base and figure out you can give them a random code base. They can work their way around and find a bug. That's what they're doing. So I've like kind of split the mandate in terms of creating new features versus like solving for bugs as a different feature set. So I wasn't a super big fan of microservices earlier in the sense that I always felt they overcomplicated my architecture than they needed to. And like I could get really, really far with a monolithic architecture. And then why I've slightly flipped towards using more microservices is because they provide really clean interfaces for the AI. So now we do have a lot of microservices built up because it's a very neat way to again like bucket AI into saying that hey, you're just supposed to do this one thing, just do this one thing really well. So having that architecture in some sense it's helped me. So I think we still do a little bit of both depending on the use case. I'm still not a big fan of OI engineering who learned it the hard way, but basically use microservices not as a design edict, but mostly as a way to chalk up or differentiate between the services. Yeah. So there essentially why microservices actually helps is what you want to so this is called context engineering, which I think is a new term that is being floating around as opposed to prompt engineering. It's basically what is the most relevant thing to give to your AI. You don't want to be giving it like the context of 10 microservices and everything that they do in the context when you're asking it to do something. What you essentially want to be giving it is just the minimal interfaces between those contexts. Basically, those microservices, right? Saying that these are the 10 microservices, this is what they do, this is how you access them, these are the edges of these microservices, and this is how you call them, and this is the main one that you're working on. So you can use these services to essentially build out this feature that you're working on, but I don't try to like pollute the context with more things than it needs to. So I keep it just it's almost as a what are you on a need to know basis. So do you need to know X? If not, then I won't put it in the context. And then we spend some time to make sure that we trim down the context instead of throwing everything into it and just giving it enough so that it gets the right thing. Yeah. I think the I've been using Figma MCP. That's mostly good. Having said that, we're not huge sticklers for pixel perfect design in the kind of startup that we're building. Again, it's like a B2B thing, so no one really cares too much about the design as long as all the features are there. But having said that, having built like a couple of side projects, I've gotten most of the way there with the Figma MCP. It still requires a little bit of ringing with the hand, saying that okay, no, the corner radius should actually be this or that, or the fonts are not actually transferring perfectly, or it's looking weird at a different aspect ratio, or it's not responsive enough, and like all of these other things come into the picture. In which case, you still might have to get your hands dirty and like code it up a bit, but by and large it gets you 90% of the way there. So you just have to work on the increment 10% as opposed to building up the basic structures and stuff.
Okay, so and then when you think about kind of the technology where it is now, what are you finding are the main limitations or frustrations you have with what we currently have?
A few things I think I'm sure will get better by the end of this year even. I think a really long horizon task is still hard for it to do. So if you go give it something that requires like you still need to babysit the AI way lesser than you did even a year ago, but still enough where you still need someone looking at it all the time to see if it's doing what you're supposed to do, etc. So I want, we're on level 3 self-driving. I want to get to level 5 as quickly, right? Like I want to be sipping margaritas while it's making me $1 million, basically. So I think we're getting there. Honestly, I think we're headed towards there, where I don't have to go babysit the AI. It can go build out of something that would take 4 hours of development time or 8 hours of development. And this is AI development time, which is like magnified human time, right? It'll go and like just spit out tokens for 8 hours and still make sense of it. So that's one. So long horizon context task. I still think we've hamstrung the AI, even though it's reduced with MCPs and stuff. We've hamstrung the AI with just giving text input. I think giving these browser tools or giving it more context about going and researching into the world, I think that makes it easier. For example, whenever I'm implementing a new library and I need documentation, sometimes the documentation is behind a weirdly structured website which the AI finds hard to get the data from, in which case I have to go and I have to like select the data, the relevant piece, and give it to AI, right? Which is like doing context engineering by hand, as opposed to it like just trying to go it and get it by itself, which it does 70% of the time, but 30% of the time it still fails. Basically and I think people are getting wise to it. So even someone like Stripe now, you can just like, it's smart enough to actually go read the Stripe documentation, the latest one, and implement it in your app, right? So basically give the model more crutches so that it can learn to walk and run, and have it more autonomous, where it can do things on its own. So those are the two general themes I want to bet will improve my life and everyone's.
When you say crutches, you mean like be able to get into websites that it's finding difficult? Or what do you mean by crutches?
Yeah. So bunch of things, right? Like I think the database thing that I said, right? Like everything that a human engineer you would expect to have access to, I want the AI to have access to those things. Those would be the crutches, right? Like I don't expect a developer to be So I expect the developer to. This is slightly off, but I expect my employee to ping me when they're stuck somewhere, but not disturb me for like every little thing. They need to have so they need to have that autonomy of saying that, okay, I only need to go ping a human when I'm stuck with this, otherwise I'll figure this out, right? Or have it access to like its own browser, or have its access to its own like database or context, stuff like that. So those would be the crutches that it would need, and honestly they're getting built out. If you know about claude.md, which is the Claude file that it creates in every repository, that basically gives it enough context about the code base. So those things are getting built out. Memory is getting built out. So once it learns about how your organization structures code, it tries to like stick to those conventions and rules, so that it doesn't try to break them. Stuff like that, basically.
And then you were talking about long horizon tasks. So are you talking about when it's acting autonomously, it kind of loses its thought sometimes?
It loses track sometimes, and sometimes you don't trust it to build out. So remember when I was telling you it went from autocomplete to building like full apps, but the full app bit also requires me to actually go and build the blueprint and build it room by room. I would much rather just give it an idea of a house and have it build the house for me, which is like which is much less involved from my side, and requires much more confidence in the AI to do the right thing. Which I think is, again, like I want everyone to try these tools out, because month on month they get better. They're getting better much faster. So things that weren't even possible like 5 months ago are now possible. So you really have to sample from reality much more often.
So in that example, right, are you kind of saying right now your kind of requirements document needs to be very detailed, and you'd rather you didn't need to provide that much detail?
Yeah, either not provide that much detail, or in between it doing chunks, right? I'm still okay like reading the requirement document once, but right now I still do a little bit of manual checking after each block is made to ensure it worked according to plan and according to spec, and it's not messing up in some obvious way. But and the size of the blocks can also increase, right? I can give it more complicated things to do. Those are the things those are trends that I think it'll continue, right? Like just as an example, this app that I was building today, the ETL thing, I didn't expect it to write the entire pipeline in one go. So I still, and when I tried to do it, it actually messed up. But then I just broke it down. Okay, just write the extraction part first, then let's write the transformation part next, and then the loading part third, and I'll make sure that all of these things work in tandem. Just that bit I think can get better and would have reduced my cognitive labor even further. Like it's already pretty low, but even further.
Right. So there's two approaches to that. One is it gets better at just simply building all of it in one go. And the second approach is you have almost like another layer of agent that is kind of doing what you're doing maybe and just saying build this piece first or this piece second and then checking. Do you think where do you think things are headed?
I think this second one seems to be the way right now, at least, is where we're heading. Like, for example, Cloud subagents have taken off. What you can ask Cloud Code to do right now is ask it to spawn more agents for itself. So it will spawn 5 agents and it will try to complete 5 tasks that are distinct enough that don't interfere in each other's lanes and basically try to build it up and give it back to itself. So Claude is doing this subagent thing where also the first thing that you mentioned, which is like give it a requirement, give it a vague idea and let it build out the entire doc piece. That also is, I think, is happening more and more. So I think we're progressing on both of those fronts actually.
Yeah, and then do you so and then if we're giving it a requirements document and we're trying to reduce the workload for the person creating the requirements document,
I
you're
like it when
basically
you're
then
writing and then you realize you're not even writing it, you're just creating it.
right, yeah. So you have the AI write it, and then you got to review it, and I suppose I guess what I'm trying to think about is like the workflow or like the way this works. So right now you're sort of still, like I said, sort of there is still a little bit of sort of waterfallish because you're still writing the requirements document in one go, and then you're breaking it down. But is there a world where you have like write a partial requirements document, it kind of creates a code base, and then you basically can actually just give it enough extra information to you're like working in sync with the requirements. It's like
Yeah.
more of like the different pieces are in sync,
Yeah.
and so you're adjusting this and the other things adjusting. Do you see that happening at all, or how do you think?
I think so. I think we're headed more towards that world. I think even the length and the specificity of the requirement document is becoming softer with each model version. As to how much you had to define to get a good output, or it's not trying to mess up in an obvious way, just keeps getting lower. So I don't have to define a lot of other things. In fact, mostly, like the most important part I've figured is actually just defining your data model. If you define your tables and your data model correctly, it actually fills in all the rest of the gaps. It's still, and honestly, filling the data model has a lot of business context to it. So it's not easy for an engineer, even an engineer, to just straight up write a data model, this thing. But I completely agree. It's still waterfallish. It's still not like agile, for the better word, but where it just keeps iterating and keeps making itself better. Do expect it to happen, but yeah, soon only itself. Like it's by the way it's going.
Yeah, yeah. Are there any types of projects where you think this type of approach may work less well, and anywhere it works more well? I guess the CRUD applications you mentioned is probably like where it works super easy or turnkey. But where how would you categorize where it kind of works well, whereas where it might be more of a struggle?
Yeah, I think like one obvious example has been where we develop stuff mostly on Python and React. Python for the backend stuff, React for the front end stuff. And this was a deliberate choice because models are really good at writing in those languages. And then we had to develop some Windows applications in C Sharp, and they're not that good at it, and they mess up way more, and the quality is like significantly different. Same for like I think native mobile development. If you're trying to write like a iOS app in Swift or an Android app in Kotlin, I think the performance is worse than if you're trying to write the same app in React Native. So I think the choice of language matters a lot. Not even to go to the kind of application, just the choice of platform and the thing that you're developing matters quite a bit, and how much performance you can wring out of these models. In terms of the kind of projects, I think like you said, the CRUD stuff works really well because there's so many examples of it in its own training set, right? And its own, so it does that stuff really, really well. When I'm trying to, so as a side project, I've been trying to train a chess model. Like I'm trying to like bring an LLM chess model, and there essentially I realized that most of the thinking is actually coming from me. Like the model is just implementing what I'm thinking at best, and sometimes not even that. Also, because these are like novel architectures or these are new things that I'm trying, that are probably not many examples of it exist in the training set. That just means that it would be worse off at that. So the heuristic that I use is that, okay, like, has it seen a million other React application in its code base? Yes, then it would do really well at React. Not so if you're trying to like do the same thing in like Go, or like Go is still pretty popular, but let's say a really obscure JavaScript front end framework that only you like. Yeah, so I think Jane Street, which is this like big trading firm, I think they use Scala or Camel. OCaml. I think they use OCaml, which is a functional programming language, and it's quite obscure. People generally don't write stuff in OCaml, and they had to train a special model just to write good OCaml, because the model performance was so much worse than writing Python. So that really matters quite a bit.
Yeah, so there's some organizations, like for example, in Amazon, or that have been around for decades and have these large code bases. And is it going to be harder for those folks to adapt versus like if you're starting a company now and you kind of have a different this kind of mindset,
Yeah.
and and the cost of development, if you have how do you think about that? If you were like one of these decades old companies, what would you do to
Good question. I don't have a very good answer given that I don't have a decades old company. But having said that, definitely I think any startup has an advantage of starting afresh, starting from this thing, latching onto the right moves. But now more than ever, because of AI, I get to structure my teams in a specific way. I get to grow my engineering organization in a specific way. I'm hiring way less than I would if I had to make the same product in a non-AI world. And my product has got nothing to do with AI. So like that just changes the economics of my entire startup. So that for sure is true. If I were a large organization, I think something that I think all CXOs are saying that, hey, everyone should at least start using these tools. Like that's the least you can ask for, and try to see all the productive gains that are happening. I think one organization, I think it was Shopify, Toby Lutke, he said that if you want to add a member to your team, you have to justify to me why AI would not be able to do that, right? Which is a good bar to keep saying that, okay, you want to grow the org, tell me why AI wouldn't be able to like already do it. So I think like even if they start there, there's so many gains in just incorporating it into your workflow. You don't have to go all the way and like build everything with AI, but just having them in your workflow is such a big boost that I expect most of these things to happen by evolution. Basically, like people who will do it will move faster in the org itself than people who don't.
right. And then do you have any sort of other sort of predictions for where you think things are headed, or where things will be in a year or any other time horizon?
I think so. I'm following AI development really, really closely, and we are on this reinforcement learning paradigm, which is the thinking model thing, that doesn't give us models that are good at creative writing, but gives us models that are really good at coding, that are really good at math. And we've just started doing the RL scaling. We've just been enjoying the fruits of pre-training so far, and now we started doing RL on these models, and we're getting like a lot of gains on them. So when these AI CEOs come and say that coding will be solved by year 2027, 2028, I believe them. I think that like it should turn into like a like my most wild prediction is that it turns into something like a footballer, right? Like you have a Messi and you have a Ronaldo who paid millions of dollars to do what they do, but most people don't earn money by playing football. It's just like 90% of the value is in like the top 0.1% of the people. I think that's where we are headed. You still have your like really large paid meta engineers, but a lot of us aren't needed actually to like go and sit and write an app. Like, is it happening in 2 years? That's my most radical prediction, but I think later or sooner it should happen. I think like there's no reason why you need to convert English into this syntax and like write like code. But yeah, I get a lot of flack for this from my engineer friends, and this is a controversial take to have.
So then in that scenario, do you think then the job description is more like essentially like product manager then, basically because you're writing the product requirements document and then maybe you're doing some testing and working with the customer, and so does everybody just become product manager? Is that what you're
Yeah,
kind of
is it?
predicting?
Yeah, I think so. I think it's the revenge of the product manager. It's like they became popular, and then I think people were not very happy with what do they do. All the work is being done by the engineer, and I think the pendulum fully shifts back to them. That hey, actually, like if you have the entire business context in your head and you know what you want to build, the who builds it part and how to build it part gets taken care of by.
Right. And then how applicable do you think, like, so we've been talking all about coding and it's been really great, interesting, valuable discussion. There are other many sort of disciplines, whether it's, literal architecture of buildings or literal, or, law firms, or
Yeah.
there's all kinds of other work. Do you think, how applicable do you think, do you have a sense of how applicable like this coding sort of revolution is just the front runner for other industries, or is there something special about coding that means it will look different for other industries or professions?
I The small answer is yes, every industry will look really different. The slightly long, more nuanced answer is industries that have a verifiable are in verifiable domains or have data sets that are verifiable will get automated first. So coding is a really good example, math is a really good example, accounting, law, whereas accounting again like has a verifiable correct answer to things. Certain kind of back office work has a verifiable, like did you fill this form correctly or not? That's probably a way to test it. Those kind of domains get automated way quickly because of the nature of reinforcement learning. But stuff like writing a brief for a lawyer as opposed to doing research, or like writing like a report of sorts, which requires like a lot of creative input, those still might take a while to really get to superhuman levels. But stuff where we have a correct answer, I think we'll start automating very, very quickly, and coding would be the first one to fall, is my estimation.
Right. Yeah. And then are you following any particular, I would say, benchmarks? So like the one thing I'm trying to figure out, I think one of the main limitations of the models, as you pointed out, is the long running context window, long coherence. And usually when these models come out, they are really talking about like, oh, I aced this exam or did this stuff really well.
Yep.
But I'm actually I feel like two things, the self-learning and the kind of coherence over long horizon tasks are actually kind of two of the more important things that need to be solved. I don't know if you have seen anything sort of tracking those things or evaluating models against those types of things.
There's a benchmark by Meter, METR, that's tracking this, saying how many tasks can it do, like how long does a task take for a human to do, and which tasks can are be done by AI. And again, we are like on an exponential there as well. Like every few months, we double the number of hours we can do this task with. So we are already up to like 2 or 3 hours or something. And so that's one. The other one is Sui Bench, which is a software engineering bench, which is I think all of them try to do, and this is more relevant for people like me who want to do real world tasks, like squash a bug, merge a pull request, write a code review. So it does all of that, and that's what measuring. And I think we were at like 30 odd percent on this like a year ago, and now we are at like 60 odd percent. I think that we just continue to climb that and we get like good engineers, but I think we're going to start exhausting that too very quickly, and we'll need like newer benchmarks for all of this. Yeah. Same.
Yeah.
Very nice.
Really appreciated the depth you went into and for sharing so much. This is really like been a really great whirlwind tour of what's possible right now and the cutting edge, how people are working. So thanks
I
so
don't
much
know,
for taking.
this conversation in like 6 months and be like, haha, remember where we were, now look at us. It's good to have
Right.
it frozen in time.
Yeah, for sure, for sure. So yeah, thanks Raghav, so for joining us.